In this video, we're going to study what we mean by a increasing, decreasing, or constant function. So let's talk about the basics first. So basics. The first one is um, we study what happens to y values. We study what happens to y values. What happens to y values of the function y values when the x values increases. When the x values increases, or sometimes we call x goes to the right. X values goes to the right. X goes to the right. So that's the kind of idea what we try to do. So we're gonna see what happen when the x values increases. What will happen to the y values of the function? Y values of the function. So this is the idea about increasing or decreasing function. So we change the x values and we watch for y values. Is the y values, whether y values goes down, y values goes up, something like that. Okay, so the next one is we can also say the behavior, study the behavior, study the behavior of a function fx of a function fx on an open interval, So when we say an interval, we mean in this section we mean an open interval. We do that to avoid confusion later when you try to study a similar topic in calculus. uh, yeah, so we study the behavior of a function, behavior of a function on an open interval I, we use the letter I, such as, so we know that we can write an open interval like this. So so we draw a line, and then we can use this notation. We can use we know that open interval you can write it like this, or you can also write an open interval like this. We using like open circles, but we do not use that for this discussion because the bracket version would be parenthesis version would be much simpler and much straightforward. Yeah. So that's the open interval, and but we use this notation. Good. Uh, so what happened now is, so and then we can write these kind of intervals like a b. So this is the interval. So if you say this is the a value and this is the b value, so this parenthesis means the corner points are not included. That's what this means. So the endpoints are not included. End points endpoints are not included. Good. The interval looks like, so when you're in this case we normally write the interval like AB. So in both cases you can write the interval like AB. So be careful. This is like a situation where we use the exact same notation for completely two different things. So we can talk about that in a minute. Again, so what happened now? For the function, the x values are coming from here. So that's an x value. So we just pick x values in this special interval. And then I also want to write this one. So this is the next one. I would say do not get confused. Do not get confused. Do not get confused with an ordered pair. An ordered pair. Ordered pair. Because we use the exact same notation for ordered pair. For example, if you have a, like, let's say, point at the x coordinate A, the y coordinate B. So we write this as A comma B. So you can see that's the exact same notation, but that's not what it means right now. Okay, so it's nothing to do with ordered pair. So this x y. Good. So yeah. So we use the exact same notation for completely two different information. Here is an interval. Interval means is all the values in between 2 points. in this case, this is an open interval, so we exclude the endpoint. So those are the basics that we want to know before we continue. Okay, so let's try to discuss what we mean by increasing and decreasing functions now. Let's look at this graph first. So let's look at this function. So we have, so I'm going to say we can start with, so this function start at A, and then there's like a drastic change at B, and then there's also another change at in between, at this point. So, and then there's a completely different change at C, and the function going to stop at D. So that means the domain is from A to D. So now let's see what's going to happen. So and then the function, we can call it y equal fx. That's the function, and the x values, and these are the y values. So let's see what's going to happen in each interval. So there are three different situations in this case. So we're going to pick a x value. So let's say I'm going to pick a x value. So I'm going to call it x1, and then so this is a corresponding value of y. So that means you go to the function and read the value. So you get y1. And then I'm going to pick a value of x1, x which is larger than x1. So let's say I pick the value x2 here. The x2 value. So you can see that x2 is larger than x1. So that means you move to the right direction. You go from x1 to x2. You move to the right direction. That's what you always do. You always go to the right direction on the x value and see what happened to the corresponding y value. So if you look at the corresponding y value for x2, you can see that the value is y2 is the corresponding value. So you can see that when x moves to the right, or when x increases, you can see the y value decreases. Y value goes down, decreases. So in the function, so this is what happened. Y value decreases. So that means this is what we mean by a decreasing function. When the x value increases, you're going to look at the behavior of the corresponding y values, and you can see that the corresponding y value decreases. So we call the function is decreasing on that region, on that interval. So the interval in this case is going from A to B. So the corresponding interval A to B. So that's the interval. In that interval, if you pick any 2 points, the exact same thing happens. Even though x value increases, the corresponding y value decreases. So we can write this there. So we can say we say the first one, function. You can say function if decreases, or you can also say is decreasing. This is like another way to say it. So you can say, you can use any of these terminology. You can either say decreases or is decreasing. On the interval, why we say on the interval? Because the exact same thing happen if you pick any 2 points in AB. On the interval AB. So we use open intervals. So that's an open interval. So you always use open intervals for this discussion. Open interval. That's like for the future. Okay. So that's the first part. And let's try to do a similar argument in the interval BC. So we're gonna again pick 2 points. So you pick any 2 points. So I'm gonna pick 1 point here. This is x3, and you can pick any other point to the right. I'm gonna call it x4. Why we do that? Because we always consider the x values which are increasing, and you can see that the corresponding y values now increases. So y3, actually y4 is bigger than or larger than y4 is larger than y3. So that means in this one, what happened, you can see function increases, the y value increases. So that means and the corresponding interval now is B to C. So it's B comma C. That's the open interval we are talking about now. the BC interval. So we can say, so now for this case, we can say a function, f increases on, you can say on a BC. So you can say it like that, on B comma C, open interval B comma C. And then next, let's see what happened in the other interval. So I'm going to go to the next interval, CD. So the next interval we are talking about is CD, and you can see in CD, so we do the same thing. So we're going to pick 2 points. One is right of the other one. So I'm going to say x5 and x6. And you can see that if you pick 2 points, it's kind of clear that they have the exact same value. So what we notice is in this region, so you can see that the corresponding values are the same. So we see that fx1, not fx5 is exactly equal to fx6. So it's the same. That's how we call it. It's the same or equal. So that means function does not change. So we call the function is constant. We will keep the exact same value. So number 3. So you can see that the function f is constant on the interval C D now. Okay, so that's the kind of basic idea about that, and it's very simple. So let's write the actual definition. What mean is, so there's a mathematical definition for this one. So let's write it now. So let's look at each definition now. So let's go to the increasing function first. Increasing function. So a function f is increasing. A function f is increasing on an open interval I. So I is like a b. So that's what we are talking about as before. So that's the open interval I. Open interval I if for any x1 x2 in the interval I. So what does it mean is you pick two elements from the interval I such that x1 is smaller than x2. So that means you're going to pick two numbers where x2 is bigger than x1, because we always need to see for increasing x what happened to the corresponding y. That's always the case. So we have fx1 is less than fx2. That means the second value is larger than the first value. Yeah. So what happened? So what we did? So there's an interval I. That's the interval I. So we pick two values. So that's the x1 value, and then you pick a value which is another value which is right of x1, because then we make sure that those values increases. So then we look at what happened to the corresponding function value. So the corresponding function value, what happened is if the value at x2 is larger than the value at x1. So if this is the case, we say the function is increasing. So simply we can see the function increases if the second value is larger than the first value. Okay, so that's what you have to remember. The second one is large. So we can see that in a graph very easily. So let's look at the graph. So this is a function, and this is the x1 value. This is the x2 value, and then you can look at the corresponding function value fx1, and this is the other function value fx2, and you can see that So in this case, actually, this is the interval you are talking about, the open interval. So that's I. So this is the interval I. And you can see that uh, x value increases, the function value actually in this case, function value increases as well. So we can draw like an arrow like that just to mean the function increases here. So that's what it means. It's very simple. X goes to the right and then y increases. So fx1, fx2, the second value is larger. So that's what we mean by a increasing function graphically. So that's the corresponding y values. Okay. So so there are a few things that we need to make sure, and then in this case we don't worry about what happened at the end of the interval. So we don't worry about what happened at the end of the interval. So so let's write them. So I'm going to say not. So these are like sometimes we get confused. So do not. Let's start it like that. And do not worry about what happened what happens at the end point. This is something we're gonna discuss in Calc 2, Calc 1 classes. And also, this is like something I wanna tell. So it is also correct to say that it is also correct to say that it is also correct to say that f is increasing or increases, f is increasing on the closed interval, on the closed interval, on the closed interval AB. So you can also say that logically that is correct, because when you pick 2 points, you're going to pick one point like A, and then you pick another point inside the interval. So and then we have the same condition as before, but only difference between these two is in this case we actually include A. In the previous one, when you have open intervals, you are not going to include A. So that's the difference between the two in these two versions. And in both cases, exact same definition works. But I'm not going to talk about too much. But we can see that the exact same definition even works for even if you write the closed interval. But we are not going to write this one because it can create problems, because there's like a relation between this and the what they call the derivatives or the slope of the tangent line. And then because what happened sometimes those endpoints, the slope becomes 0, so there's no increase, and then that can create a problem, a confusion. So because of that, we are not only we don't talk about closed intervals, we only talk about open intervals. But it's okay to even write closed intervals if you want. So let's say but we do not use this version, but we do not use this version. We do not use this version to avoid confusion later. To avoid confusion. To avoid confusion later in Calc 1. Later in Calc 1. Okay, because we can relate the increasing decreasing function with derivatives, and there are problems. Because we normally say that, so I'm going to write this one just for future. So we sometimes say that f is increasing if the derivative, we normally call the f prime, if the derivative is positive. So that is something we're going to use. So that means we can use this idea anymore if you use the closed interval and there are problems. So we can avoid that. Okay, that's about that. So let's go to the next one, what we mean by a decreasing function. So B, the decreasing function. A function f a function f is decreasing, a function f is decreasing on an open interval, on an open interval, on an open interval I, if for any, so you pick any 2 points, for any x1 comma x2 in the interval such that x1 is smaller than x2. We have now what happened, the second value is small, that means fx2 is small. So it's very clear. So we say decreasing if the second value is small. This should happen for all the points. So for any, if there's a problem with at least 1 point, and then it's not increasing anymore, you have to be careful with that. So this is also clear from a graph. So if you look at this graph, so let's say we have this graph going like that, and then you can see that if you pick any 2 points, so in this case, so this is my interval, so it's starting value and the end value, we consider only open interval. So look at the corresponding value. So this is x1 and this is x2, and you can see that if you look at the corresponding function value, this is fx1 and there is fx2, and you can see that the function, when the x value increases, the corresponding function value decreases. So that's why we call this is a decreasing function. You can put an arrow like that. It's a decreasing function in this interval. So it's a very simple idea. So what happened in this case, if you look at the two values, x1 and fx2, it's a good idea to write it in this order, then you can see what happened. So you can see the second value is smaller. Okay, so let's look at the next one, the constant function. So the constant function, so we're going to say a function f is constant, a function f is constant if a function constant, again actually you will add the interval. You can say a function is constant on the interval I if fx is the same, for all x in the interval I. What does that mean? You pick any points in the interval I, so you can see that they are the exact same values. You're going to get exact same values. So in a graph, it's very clear. So if you look at the graph, what this means, so if you pick any 2 points, x1 and x2, you're going to see the exact same values of the function. You can see these two values are exactly the same. You can see they have exact same values. So this is the fx1, but you can see they are the same. So you can see fx1 equal fx2. So you cannot distinguish the two. So that's what we call a constant function, same values. Good. So that's the theory. It's a very simple idea. So let's look at some examples now. So as the first example, let's look at this graph. So this is the function we have. So this is the y value, this is the x values, and then this is 0. And then you can see there's a peak at, let's say 2, and then there's another different behavior at 3, and the function stops at 5. So and then you can see that on the first interval, so there are 3 intervals here we can talk about. First interval is going from 0 to 2. In that interval you can see function increases. So this part, the function increases. And the second interval is we have 2 to 3. The second interval is going from 2 to 3. So in that part, you can see the function decreases. And then the third interval we have is 3 to 5, and you can see there the function is constant. So we can write it like this. So we can see that so f is increasing, on 0 to 2. You can see on, we just say on 0 to 2. So we don't want to say like in the interval. You can, it's clear on the interval. So 0 to 2. It's just, again, it's not a ordered pair. So that's what you have to think about. Okay, it's an interval, not an ordered pair. So don't get confused with that because it's the same notation. Okay, and then we also say, we can say the next one. So if is decreasing, or if decreases on the interval 2 to 3, and then you can see f is constant on 3 to 5. So that's what we observe for this one. So let's look at the next one, number 2. For this one, we can look at the graph of the absolute value function. So the graph looks like this. So the x values and the y values. So yeah, we can put two arrows like that, and you can see. So in this one, there is no like a clear intervals. So you can see the x value can be can goes to actually infinity. So the starting value on this one is negative infinity. That's where we can start. And again, for the what's the largest x value, that's the infinity. So that's where we're gonna stop. So that means so when you write the interval, so you have to write the interval like 0 to infinity. That's one interval, and the other interval is 0 to negative infinity to 0, and the other one is 0 to infinity. So those are two intervals that we're gonna talk about in this case. Okay, so when it's clear that in the first interval from 0 to negative infinity to 0, the function goes down, and the other interval you can see that the function increases. So we can see that so we can write decreases. So decreases on negative infinity to 0, and increases on 0 to infinity. So we do not include corner, like when you have infinity, we never include the corner points, but we can include 0 here, but we do not for the consistency later. Okay, let's look at the next problem. So we can look at the graph of y equal a negative x squared plus 3. So how are we going to look at this graph? And you can see that we know the x squared is the parabola, but when you have the negative sign, what's going to happen is it's going to flip over the graph, and then we add 3. So that means we're going to move the whole graph up 3 units. But we can discuss these things later when you talk about transformations. But so that means the graph going to look like this. So in this case, it's going to go indefinitely to negative infinity. So we put arrows like this, so 0, x and y values. And you can see this is the largest value, which is 3. That's not a concern right now. What the value is. Okay, so again, so the interval is going to look like in this case also as before. It is going from negative infinity all the way to 0, and then start at 0 and goes to positive infinity. Those are two intervals, and we can see it's very clear. In the interval going from negative infinity to 0, the function increases, and then the interval from 0 to infinity function decreases. So we can say increasing on let's try the decreasing yeah, increasing on the interval negative infinity to 0, and then decreasing on the interval 0 to infinity. Okay, so it's very clear. So let's look at the next example, number 4. So we're gonna look at this graph. So we have so the graph so it's gonna start at -4, and then there's a value. This is at -2. So I'm gonna call this value is -2, 2, -2, -2. So you can see it's -2 and -2, and then 0. And then this value is let's say 2, and then 4, and then 5. It's value at 5. Okay, so this is a graph, and you can see from the interval. So there are different intervals now. So in the first interval from -2, -4 to -2, you can see the function decreases. And also you have an interval here, you can see the function decreases, function goes down. So now the question is how to write this interval. So what we're going to do, we're going to have the two intervals. So there are two intervals now. So there's a one interval going from -4 to -2, and there's another interval 4 to infinity because there's no end. So that means on those both intervals the function decreases. So that means what we're gonna combine them. How to combine them? We use the union notation to combine. So we're gonna say if you say the function y equal fx, so you can say f decreases, on. So write the two intervals and put the union for that. So you can say -4 to -2 union 4 to 8, 4 to infinity. So you can see it's -4 to -2, and then put the union, and then you write the second interval. So that's the notation we're going to use when you have two intervals where the same thing happen. Okay, so now, and then you can see the next one from -2 to 0, the function increases, and also from 0 to 2 function increases but with different rate, but it doesn't matter. You can see in both intervals the function increases continuously. So that means we just say one interval for this problem. So we are going to split this into two. So we're going to say f increases on, we're going to say simply -2 to 2. So those are the, we only write the x values here. Increase on the interval from -2, start at -2, and then ends at 2. That's how we write it. And then the last one, we can see that f is constant. F is constant on the interval from between 2 and 4. So you can see between 2 and 4, the function stays the same. So it stays the same. So it's constant. So if it's constant on, we can say 2 to 4. So that's how we write the intervals for complicated functions like that. Okay, so let's do one last problem. Number 5. So we have this graph. So this is a graph we have, and you can see that this is a special kind of graph, and we have several properties that you're going to learn later. So you can see that when the value x value is very very small, you can see the functions goes to also become larger and larger. So these kind of situations are what we call asymptotes. So we can talk about this this in detail later. Okay, so let's look at the corresponding values now. So there's a value here, so I'm going to call it 2, and then let's say this is 3, and then this is 5. And then also something interesting happen. You can see that this value when x is bigger than 4, you can see the function decreases, but what is the smallest value? We don't know. We don't know what's the smallest value, but we can still see that it's getting smaller and smaller and smaller, but it never becomes 0. It's getting smaller. So these are interesting situations. So these kind of situations are what we normally call horizontal asymptotes. So it's going to get closer and closer, but it never reaches the value. Okay, so let's see what happened in this case now. So we can split this. So we can see the function decreases on the interval 0 to 2 and 4 to infinity. On this interval, on these both intervals, the function decreases. So it decreases in this interval and decrease on that interval. So let's write it. So you can see So if you call y equal fx again, you can see f is decreasing. F is decreasing on, so there are two intervals now again, 0 to 2. So we have two intervals, so we can say 0 to 2 union 4 to infinity. That's one interval. And then you can see that the interval from 2 to 3, you can see the function increases on that interval. So you can see f is increasing on 2 to 3, the interval 2 to 3. And then also you can see in the interval 3 to 4, the function has a constant value. So f is constant on the interval 3 to 4. Okay, so this is the idea about increasing, decreasing, and constant functions. So you can do some practice problems now. Thank you.